Hi, this is Hanson Lee doing AP Physics 1 FRQ1 version D. This is Hanson Lee. Sorry. A. Draw and label the forces acting on the block for the inclined segment. Let's just draw it out. So we have the normal force, which is because it's on a surface. We have FG, which would be longer because if you just draw FGY, the component, it would be the same as Fn, but less than Fg because Fg would be the hypotenuse for the imaginary triangle. You also have Fk going upslope because the box wants to go downslope and it will be opposing that. So yeah, you can see that. B, determine the angle theta of the ramp. So we know that, so the position time graph given shows a constant slope because there's no curvature. And the slope of a position time graph is the same as the velocity, which means with a constant velocity, A equals 0. So it'll help us in F equals ma. With the two forces acting on it in the x-axis, Fgx minus Fk going the other way equals 0 because we know A is 0. Let's move over Fk. Now we can begin to solve mg sine theta because it would be sine because the opposite, and then Fk, which would be mg cosine theta times mu k because it would be Fgy times mu k. Cross off mg to make things easier. Sine theta equals cosine theta times mu k. We know mu k is given actually, so this would be 0.3. So sine theta equals 0.3 cosine theta. Let's get rid of cosine theta by dividing on both sides. So sine theta, cosine theta, we can just turn this into tangent theta equals 0.3. And then we can do arctangent both sides to find theta. So arctangent of 0.3, theta equals 16.7 degrees. C. Calculate the coefficient of friction of the horizontal flat segment. So it's important to know that the only force acting on the block during the horizontal flat segment is Fk. So let me just show that out. Fk equals ma. We can't use the same A because this is for the horizontal segment, this is for the incline. So we have to find A. And to find A, we have to find something else first, which is the velocity on the incline segment, which doesn't change. To find the velocity, we can use the position time graph. X2 minus x1 equals change in y over change in x, which would be the slope, which is the velocity of a position time graph. Let's do 10 minus 0, 5 minus 0 equals 2. V equals 2. Got that? So we're gonna actually have to do the same thing again, because when the block leaves the incline segment, the velocity, this becomes Vi, and it applies to the velocity time graph for the horizontal segment given. So we know that that top point at the very top left would be 2. And the reason why we do that is because we're going to find the acceleration, which is the slope of velocity time graph. So we're just reusing this again, but for a different graph. So 0 minus, now we know 2, and 10 minus 5, negative 2 over 5, A equals negative 0.4. Let's plug that back in. First off, this Fk is now just mg mu k equals m negative 0.4. Let's get rid of the m's. To find mu k, divided by g on both sides. Negative 0.4 divided by negative 0.8. Negative 9.8. 0.004. So mu k is 0.04. Okay. G. How much distance is needed to bring the block to a complete stop during the flat segment? From the velocity time graph, you can see velocity becoming 0, which is coming to a complete stop. Also from the velocity time graph, we know that the area under the slope is the displacement. So to find that area, we do 1/2 base times height because it's a triangle. 1/2, what is the base? 10 minus 5? 5. What is the height? 2. So 2 times 1/2 is just 1. So we have 5 meters needed to bring the block to a complete stop. E, calculate the block's average speed during the horizontal flat segment. So the thing about average speed is that it's equal to the total distance over the total time. And we actually know both of these. Total distance, we just found 5 meters. And from the graph, the total time it took to go 5 meters, 5 seconds. So this means that the average speed is 1 meter per second for the horizontal flat segment. Okay, F, sketch the shapes of the corresponding x versus t graphs and a versus t graph for the horizontal flat segment. X versus t, well, it's still going in the positive x direction, but it is as a negative acceleration, concave down. And for AT graph, what we just said, say this is -1, constant acceleration, but it's negative, which is -0.4. So this is why it's like around a little bit more than -1. Yeah, G now. If the you already know. Okay, to find the distance from the base, we can do this. Displacement x equals VIT plus 1/2 AT squared. There's no acceleration in the VIX direction or the x direction as it's moving. We actually don't have VIX or t, so we have to actually find those. And to find VIXT, let's keep this in mind. F equals MA. So this is going to be for the horizontal flat segment, and remember the only force on it is FK equals MA. Let's turn this into mg mu k equals ma. So, but since we find mu k, we know it's 0.04. So 0.04 times g equals acceleration. So acceleration would be -0.392. So why do we find acceleration? Because the VF for the horizontal flat segment is going to become the velocity for when the block flies off the ground. And how do we find that VF? We do VF squared minus VI squared for 2A equals displacement. The displacement, remember, was 5, but this time it's a third. So Vf squared, you see that? Yeah, Vf squared minus Vi squared equals 2. Let's start plugging this in. 0.392 equals 5 over 3, which is 1.67, or 1.666 repeating. So 2 times 2 to get it from the bottom, and times 0.392. Vf squared minus Vi squared equals 1.3067. What is Vi squared? Vi squared is, Vi is 2 for this part, because nothing on the incline changed. So this would be 4. To cancel it out, we add 4 on both sides, because 2 squared equals 4. So Vs squared equals 5.3067. Square root both sides. Vf equals 2.3 meters per second. But this is the Vf for the horizontal flat segment. So we can actually use this. As the block flies off, this becomes the Vi. So we actually have found Vi because it's just going horizontally. So we have Vi, but we need T. How do we find T? Well, we actually have to do this. The same formula. We can actually do a lot with this formula. There's no VIY because remember, it's just going horizontally off the ground. We know the height, 10, which would be negative 10 because the displacement is going to go down, equals 1/2. Remember, this acceleration is different because it's just going to be gravity. The acceleration of gravity. T squared. So times 2 will cancel this out and divided by g. So negative 10 times 2 divided by negative 9.8 is 2.04 equals t squared. T equals 1.4, let's say 3. So we actually have both parts now. We have Vi and T. So it's going to be 1.43. Remember, there's no acceleration in the x direction, the x-axis. So this would be Vi and this would be T. So 1.43 times 2.3. 1.43 times 2.3, which will get you around 3.23 meters from the base. Okay, that is G. H. So if you double the height to 2h, then the x will also double. We actually can plug this in right back into this equation, because this is the part being affected by it. Remember, there's no VIY, just going horizontally. So this would actually become negative 20 equals 1/2. Remember, G t squared. So times 2 times 2, negative 40 equals gt squared. Negative 40 divided by negative 9.8, t squared equals 4.08. So we get our new time to be approximately 2.02. Let's plug that back in. Remember, no acceleration in the x-axis. So VI actually won't change because it's just changing the height. So this would be the same thing, which would be 2.3 times 2.02, which is our new time. This would be around 4.65. So our old distance from the base was 3.23 meters, and our new one is 4.65 meters. So the x did not double, and we can see like a major reason for that because even if you multiply this times 2, t squared is going to make you do a root, so it can't be exactly 2. So yeah, the student is wrong. The physics student is not right. That's it.